Mathematics often feels like a foreign language trapped behind glass, a collection of symbols locked onto a flat, two-dimensional surface. Compare that to the digital animation canvas. This is a vacuum of physical freedom, where anything you draw can be pushed, pulled, and brought to life. These systems operate on fundamentally conflicting logic. Math relies on absolute abstraction, while animation relies on manipulatable reality. This is what happens when those two worlds occupy the same space. We start with a simple character in a blank void. Here, the animator has total control, giving the character extreme physical elasticity and momentum. The conflict begins when a basic mathematical symbol drops into the frame, behaving like a rigid, uninvited physical object. The character tries to handle the number like a standard animation prop. They push it, they pull it, they try to stretch it. But the physics of the canvas fail. The symbol does not yield to kinetic energy. Force alone cannot alter mathematics. To survive this encounter, the character has to learn the underlying logical rules that govern the numbers. By interacting with this multiplication symbol, the character discovers that basic arithmetic dictates the cloning of matter within the canvas. These operations trigger an immediate physical reaction as the character's body splits into identical clones that crowd the screen. With a surplus of bodies, the character leverages the animation principle of timing. By staggering the movement of these clones, they can effectively rewrite their own frame rate. In a visual space, arithmetic functions as the direct control of time and matter. The threat escalates as complex geometric shapes begin crashing down into the arena, turning the blank void into a hazardous maze. Survival now depends on staging, the deliberate placement of objects and characters. The character must read the geometry of the architecture to find a safe path. Using the Pythagorean theorem, they plot an exact escape trajectory, dodging falling shapes and calculating the spatial vectors of the environment. Angle calculations allow them to turn the shape's own geometry against them, bouncing projectiles back to clear the field. Geometry provides the architectural blueprint for the physical world, giving abstract shapes mass and boundaries. The conflict reaches its peak as the character is pulled into the interface of a massive graphing calculator. This complex equation functions as a physical balance scale. The equal sign acts as the pivot point, and the whole system is teetering toward a collapse. The x and y variables behave as volatile forces that must be physically wrestled into position. To manage the chaos, the character uses animation keyframes to freeze variables in midair. Dragging a positive integer across the center equal sign changes the number's visual properties. This rule of inversion maintains the equation's structural integrity as parts move across. Algebra is a visual balancing act. Each moving part must achieve equilibrium to keep the system from falling apart. With the balance restored, the struggle ends. The character and the mathematical symbols begin to move in sync. Look at this fractal pattern. The character is using the logic of the equations to build complex, blooming structures that would be impossible to draw by hand. This reveals the actual relationship between these two worlds. They were never truly in opposition. Animation is math rendered visible, a hidden engine calculating vectors and physics behind every frame. Mathematics acts as the framework that dictates the rules of the visual world. When abstract math feels impossible to understand, it is often because we are missing the physical context. We are looking at the engine's code without seeing how the machine actually moves. By translating rigid equations into kinetic characters, the abstraction disappears. We can understand the rules of the world once we see them in motion.